Dear students, we are going to continue with the alignment design. That is the module we started in the previous interaction. In the previous interaction, I tried to give you an overall picture of what we are going to talk about in this particular module in the coming lectures, and I hope that you have been able to understand that what are the various elements or the broad categorizations in the area of the alignment, fixation and design which we need to tackle. In that direction, we looked at the possibilities of having the horizontal alignment, vertical alignment, and towards the end the coordination of those alignments. When we were discussing about those type of things, we came up with various factors which govern the fixation of the alignment. And in today's interaction, we will try to look at those particular factors in more detail, and if the time permits that we are going to look at the surveys also in succession with those particular factors. Let us start with the factors which governs the alignment design. Now, the very first thing which we need to look at is that whatever alignment we are going to provide is easy in nature. Now, when we say easy in nature, what does that mean? Now, if we talk about the contours, as we have taken an example of that, when we are looking at that we need to have a connectivity between A and C via B or between A and B via C and D, then these contours play a critical role because they are defining the levels, the elevations with respect to either the reference point or the mean sea level, whatever the way the datum has been fixed by you when you plot them. And if you are looking at the survey of India's sheets, then of course they are with respect to a specified datum or reference point which is coming from the mean sea level. So, when you talk about this and when we say that there is a contour like this, and this particular contour is being defined as 10, 20, 30, then that means if you keep moving along this contour like this, you are moving at the same elevation. And if this is possible while connecting the various locations, this is the best thing which can be there. Or there may be a possibility that we can move from 10 to 20 not in this form, but we can move from 10 to 20 say in this form, and when we do this, what happens is that the elevation which is going to be there along the length is being gradually introduced. So, when this is being gradually introduced, then also it becomes easier for the driver to traverse that. So, when we say that, we are going to look at this change in elevation, and this change in elevation is happening as 10 to 20 to 30, and if we talk about that this particular distance is not much, say this is something like 10 meters or 20 meters again. So, it may turn out to be 1:1 or 2:1 condition, and this 1:1 or 2:1 condition, whether it is easy for the vehicles to traverse is what we are trying to look at, and that is the location where the ruling gradient comes into picture. And of course, we are going to talk about the various other gradients also when we will take up the vertical profile or the vertical alignment. But just to have an idea that the gradient which we are going to provide here is a sort of a ruling gradient, and if we are in a position to do that, say this is a ruling gradient. If anything goes beyond this like this or this, then the resistance increases a lot, and if this resistance increases a lot in these cases, then the vehicles may not be able to traverse it continuously for a long distance. Either we have to reduce their distances with these type of gradients, or we have to provide some other mechanism so that the vehicles can get the power again and then traverse the another such gradient which is coming along the route. Now, when we are looking at this thing, the another aspect is a resisting length. Say we are going to connect point A with respect to point B, which is at a height E. Now, when we are connecting this and we say that we are going to connect it by a certain value 1 in N1, then this 1 in N1 is feasible or not with respect to the vehicle performance is another important thing. and we may found that we need to do it is 1 in N2, and this 1 in N2 is such that it is less than N1, and that is where what you found is that this is going to be something like this in this form. So, you still reach the location B, but your length which was L1 has increased to L2. So, this value of 1 in N1 which has got, now what we have is this particular length L2 which is feasible at that, and that is where we are talking about this resisting length. This is another aspect. Then the next thing is the operational requirement or the performance of the vehicle. I have been talking about this again and again in continuation with the other things. So, we are looking at, when we say the performance of the vehicle, we are talking about the motor capacity, and we are talking about, because this motor capacity is going to translate it into speed. So, are the vehicles in a position to negotiate this with a speed V, and if they come to this one, then the speed becomes V1 which is less than V. Now, what is this drastic reduction? It is a drastic reduction, it is a reduction which is allowable, permissible, and that is going to define whether we can go for 1 in N1 or we need to remain with 1 in N2, or we can increase 1 in N2 a little bit to 1 in N2 dash. What exactly is that? Now, another aspect other than the operation, other than the way we are talking about, is the construction. Now, whatever profile we are trying to talk about, if we can have it in such a manner that the construction activity can be taken up in a easier format, then this is another aspect which we should try to take into consideration when we are fixing an alignment. So, these are few things which we need to take care of when we are talking about the factor easy. Now, another aspect is short. Now, short between point A and point B is always a straight direct line. So, if you can provide this a straight direct line is fine, but in many of the cases it may not be possible, because you need to look at what type of terrain it is in which you are going to provide it. And based on that, it may happen that you may not be in a position to provide a straight one, rather than you have to do it through C and D. And this C and D may not be only an outcome of the terrain, it can also be a case where the various towns and cities are there in the vicinity of the alignment, which you are trying to talk in terms of a direct one. And if you connect this town 1 and town T at a location C and D, then this is again a beneficial aspect. So, the trade off is between short versus long, between direct versus many connectivity which can be there, and we are also looking at the operational feasibility in terms of the traffic volume which is carried. That is another aspect. So, if you are going from A to B directly, you may find that the traffic volume from A to B is say T1, but when you are going from this one, or instead of T1 we can say TV1, but when you are going from A to C, C to D, D to B, then this is traffic volume TV2, which is much greater than TV1, and there is where it makes it more feasible to operate this particular route rather than having a direct route. So, again you have to take into consideration these, you have to decide on the basis of that, have to take a judicious decision, and then the final alignment is going to be there. So, when we see this and when we are talking about this, so the connected aspect which comes up is the connectivity. Now, this connectivity we have to see whether only the major towns needs to be connected and the minor towns are going to be provided with the side connectivities. So, I am saying that I am going from A to B to C to D and all of these are major towns, but at the same time there is P or there is Q or there is R, which are the minor towns. So, these are the minor towns which have been connected by way of a side road to the main connectivity, and that is how the connectivity has been enhanced and the network has been enhanced in that particular area. Now, when we are looking at these type of connectivities, when trying to see that whether my alignment can pass through that, and when we are taking into consideration the terrain, as again and again we talked about. Now, one aspect which is there is a set of obligatory and non-obligatory places. Say if we say obligatory, the town which needs to be connected, that is an obligatory location, you have to go through that. Or say there is a river, you need to connect, you need to cross through that. So, a bridge has to be constructed, or as we said before, a tunnel has to be constructed in the hilly terrain if the hill is quite high, and going by circuitous nature is going to result in a lot of time which is to be devoted. So, there can be different such points which may fall into obligatory conditions, but there can be a set of non-obligatory places. Say if you talk about a lake, so there is not advisable that whatever the lake is there and you are coming with the profile from A to this point B and then there is a point C. One way is that you think of connecting it like this, but rather than that, the better way of connecting it is that you go into this form rather than this one. So, that is a non-obligatory location, or a marshy area, that is also, or a say a religious place, we should not pass through that, we can just deviate, detour and do that. Now, when we are looking at these things, the another aspect can also be a bypass, that you have the cities. So, this is a municipal limit of a city, but lot of habitation is there, dense population is there, and our alignment is coming like this from A and very near to the city like D. Now, one way is that we provide a bypass and come to the location C and then goes to D. So, instead of crossing through the city, we have detour our alignment and a bypass has been looked at, and of course, this bypass may have few connectivities with the city. So, that the traffic from the city can come to bypass and can go from bypass to the city depending on the location where you are in the city or where you need to go to the city. So, those type of things also needs to be taken care of. But whenever whatever these particular decisions are being taken, one another big aspect is the traffic, and this traffic has to be taken into consideration. Now, when we talk about traffic, we are talking about the volume. How much traffic is there? 1000 vehicles per hour, or we can talk about 1200 PCU per hour. Different notations are there, and these particular notations we have discussed when we are talking about the various factors. So, what is PCU, what is this traffic? So, when we are looking at this particular volume and we do the studies related to the traffic, say we do for OD study. OD study is origin destination study. Now, when we have this origin destination study, this origin destination study will result in a traffic desired lines, which will define that there is a traffic going in this direction, or traffic going in this direction, or traffic is going in this, or is going in another direction. So, there are different directions in which the traffic is going from a location A is going to be depicted by these desired lines, and at the same time the thickness of these desired lines is going to tell that how much traffic is going to move from A to say B or C. So, the thickness whatever is being provided here defines that this is going to be more, and if it is quite less, then that says that it is going to be very less in this particular direction. So, that amount that is what we are going to get an idea, and this particular thing can tell us that how we should provide our connectivities. So, if we can provide a connectivity like this and this, that means the both B and C have been satisfied by way of the provision of a facility, and we have subsided the traffic, these two particular traffics which are quite high. Or there may be a possibility that we go from A to this one and C, but for B there is a separate connectivity being provided. So, it all depends that what are the further other cities which are there in adjoining areas or in the region, and we can take care of that. So, when we look at that, that means we are trying to satisfy the demand in that particular area, but at the same time, depending on that what is this volume V1, V2 etc., is going to translate into the number of lanes which are required per direction, and that means this is going to further define what is going to be the size of a facility, because there are other features also in the cross section which has to be provided along with these number of lanes, and we are going to get a good width, and that is what is the size we are talking here. So, the traffic considerations are also going to talk about this. Now, when we are looking at this size of a facility, this is being taken care of by the transverse levels which are being done with respect to the center line profile as we discussed previously. So, that this is the location where we are saying that if this is the center line and we have to go in this direction by a distance d. Now, this distance d may be like say 25 meters on this side and 25 meters on this side, or it may be simply 5 meters on this side and 5 meters on this side. It all depends at what type of a size of a facility, type of a road which needs to be provided. So, we need to collect this information when we are going for a survey. Then the next aspect is the profile, whatever we are trying to provide and we are trying to fix, that should be economical in nature. Now, economical in nature means we can look at different aspects here. We can talk about the construction, we can talk about operation, and we can talk about the maintenance, because this is also important. After some time period your facility is going to deteriorate and you have to maintain it. So, when we are looking at all of these things, when you say construction, it means you are looking at the material, you are looking at the manpower, you are looking at the use of machine. When you are talking about the operation, you are talking about the vehicle movements, and maintenance is different. So, we have to see that when we are trying to fix up what amount of earthwork is required, and when we say the amount of earthwork, we are looking at the cutting and we are looking at the filling along the profile, and whether the cutting and filling they are getting subsided by each other or not. The construction, what type of machinery is required, is going to be a very specialized job. Say if you have to go for a tunnel, then it is going to be a specialized job and the cost of your project is going to increase. But if it is a simple profile, then the normal machinery can work. So, that is the point which is there. Availability of the material, whatever construction is going to be there, whether the material which is available is satisfying the specifications with respect to the MORTH document related to the specifications for roads and bridges. So, if that is not available, then it is a problem, you have to get it from somewhere else, but if you do that, then the transportation cost of that material is going to add on to their project, and that will increase the cost of project. So, we have to see how the material which is locally available can be utilized, and if we can modify it and utilize it is the best thing. Then the maintenance requirements which can be there, they may be because of the snowfall in that area and you have to remove the snow, and when you dredge out the snow, then there are possibilities that the top layer also gets affected. So, you need maintenance for that. In the desert area, there is a lot of sand which comes on the top of the surface of your road, and when the vehicles moves at the top of it, then there is an sort abrasion condition can be there, and that is deteriorating the surface, or you are in marshy areas, or the gradients etc., which have been decided are going to define whether the operational economy is going to be there or not. Now, when we say that we are going to provide an easy, short, economical, traffic oriented facility, and when we have said that we should try to provide a connectivity from A to B which is direct in nature, and say this is something like 50 kilometers. The one problem which is going to be there with the driver is that the driver knows I have nothing to do, my steering remains in the same position, this road takes me for 50 kilometers straight without any change in direction etc., and therefore, the drive will become monotonous in nature, and when it becomes monotonous in nature, then it brings in the reduction in the alertness, and you driver may feel like dizziness can be there, and the safety is going to be hampered. And this is one of the reason that instead of having a continuous straight profiles, we try to have the combination of the straight profiles with the circuitous profiles. So, some change in direction is going to be there after certain kilometers, and if say you can do it maybe after 3 kilometers, every 3 kilometers a bit change is there, then the driver remains alert and the safety is going to be maintained. So, this is another aspect which can be taken care of. Environment is another aspect, and when we are looking at this environment, then here the various permissions may be required, and it all depends on that what is the type of the project, what is the size of the project. So, the type and size of road project will define whether you need to go for it or not. But this is important because the flora and fauna in that particular area is going to be affected, and if they are going to be affected, we need to preserve them for our generations to come, and that is where whatever the requirements, whatever the changes are there with which this can be done, we should try to do that. And that is the reason the environment is another factor which we should take into consideration. And here when we are seeing this particular environment, we are talking in terms of the ecological aspects primarily. We are not talking about the climate in terms of rainfall intensity on that is another part that we can talk about. Now, in few of the cases it may happen that you have provided an alignment, but there is a river which is going like this, and therefore, there is a requirement of providing a bridge at this particular location. Now, when we are going for this, then what type of information you need to look at? So, you have to go for an hydraulic information, and this hydraulic information, depending on that what type of terrain, what type of conditions are prevailing at that location, may result in different sets of information or a combination of those information. So, if we talk about say river, we have to look at the discharge, we have to look at the high flood level which is defined as HFL. So, up to what particular level the river, this is the say the bottom of the river, and the high flood level is here, then our road has to be at this level with some clearance. So, there is a gap which needs to be maintained. Okay. And this you might have studied in the water resources. Okay. So, we have to see that what are the fluctuations in high flood level, how much it goes up and down, what is the width of the water body. So, if you are talking about say a river is coming like this, but at some location it changes in this form and then it goes in this way. And if you think of providing an alignment at this particular location, then this will result in a very big bridge facility, and this is not a good option. So, what we can do is that this alignment can be changed to this one and goes this way and then goes back, where the bridge facility is smaller. So, construction cost for this particular bridge is also going to be less. So, we need to take that also into consideration, and when we are looking at this particular area, now one aspect which may happen is that the meandering nature of the river. So, at this point if the river is changing its course, its width, than if you provide a bridge here may become useless after certain point of a time, because the river has shifted its location. So, we have to see that whether there is a requirement of a bridge, what type of bridge needs to be provided, what is the type of the structure which is going to be there of that bridge, how many spans, how much weight, etc., etc. They becomes the related associated factors which has to be taken care of and into consideration when you are talking about the alignment which passes through such bodies. Some cases you may find that there is a subsurface flow, and this subsurface flow, whenever there is a optimum location, this water will come out. Say you have a hill. So, the subsurface flow is there, but at some location this water may come out, and at this particular location if you have provided a carriageway, so it is going to be difficult. So, we have to take care of the things, and when we are taking care of these particular things and we are taking care of the fluctuations in the groundwater table, we have to see that what type of say the drains or the cross drainage works which needs to be provided, so that the water which comes here gets to the other side and goes to the valley without creating a problem to the crust or the pavement which is being provided there as a part of the alignment. Similarly, the surface flows needs to be taken care of. There is a precipitation, the rainfall is there, and therefore, the water will come flowing like this. So, you have the surface flow which is there, and this surface flow needs to be taken care of by way of the catch drains or by way of the longitudinal drains, so that the water is accumulated in that, and wherever it is feasible, it is being taken out of the system without creating any problem. So, these things also needs to be taken care of depending on which particular terrain and what particular conditions your alignment is passing. Then geological factors are also there. Now, in the case of geological factors, what are the things we can talk about are like the faults, fissures, folds and dips. Say I am talking about the hilly terrain, I have to provide a road in this particular one. Say I am going to provide a road here. So, this is my road. Now, if I find out that how the stratifications has been there in this particular hill, and I say that these stratifications has been like this. So, this is the dip of the stratification, and this dip of the stratification is in this direction, and therefore, it is going to remain stable. But say if this has been in this form and we have thought of providing a road here, then what will happen is that this is going to flow out. There is a possibility that this material will flow out and it may result in say landslide, and this is not an optimal condition. Similarly, there is a possibility that you have the profile of the area is like this, but at one point what you found is that there is a fault. So, that this strata has broken at this particular location, and there is a possibility that there is a relative movement of this either in this direction or in this direction, and if we are trying to provide a road at this location, it is obviously going to crack whenever this type of a tectonic movement is there. So, this is another important aspect which needs to be taken care of, and the same is the condition that you have a strata which is like this. So, this is fold. Now, depending on these particular folds, the dips where you are going to provide your road is another aspect which has to be taken into consideration. And when we are looking at that, when we are talking about these widths to be provided, that is what is the road formation width, and this is another aspect we are taking and considering here. And all of these things are apart from the rivers and tunnels which may be a requirement in a hilly area, depending on that whether you have to cross a particular hill with a shorter period of time or so. So, when we are looking at all of these things, then this may also result in a drainage condition, and these drainage conditions means you have to look at the drainage pattern. Say there is a this watershed line and there are connectivities like this, so that what you found is that the water drains in this direction and the water drains in this particular direction like this. So, this is a drainage pattern of a particular area, and now how you are going to provide your road in this particular pattern is going to decide whether your road will remain long lasting and will fulfill its design life, or it will not do that. And that is where this watershed line is another aspect, that you are on a sort of a ridge and then the water flows in the opposite directions like this. So, this is a water shed line, and if you are providing your profile along this one, then probably it is not going to be a problem, because then water is not going to create an issue here. The cross drainage works is another aspect, because if the water is getting accumulated, has to be taken away and out of the system. And when we are looking at these things, as I said, the different types and sizes of the bridges etc., or connectivities etc., has to be seen. So, it can be in terms of a submersible bridge, it may be as a culvert, which can be a box culvert or a pipe culvert or a causeways, or there will be a simple water which is coming as a surface runoff, which is being taken into the longitudinal drain, being collected and then disposed of. Apart from all of these things, the another thing which we has to take into consideration is that it satisfies the regional plan. And when we are talking about this regional plan, it means we are looking at the various cities, towns, villages etc., which are there, which needs a connectivity, or we need to provide an accessibility to a particular remote area, so that that area also starts developing. We have to take into consideration how fast the movement can be provided from one location to another, and that is where now we are talking about the expressways, we are even talking about the rail systems like rapid rail systems, or we are talking about the high speed rails etc. So, they are all part of those regional plans and the planning, and the demand requirements which are there at the regional level, which needs to be satisfied by way of providing all of these facilities. And the final thing which needs to be taken care of is the aesthetics. Aesthetics means the whatever plan, whatever elevation which is being provided, they should look good and pleasing, and we should try to look at this particular aspect, and that is where the perspective of driver or user is becoming an important thing, and we will be talking about this thing further when we will be looking at or discussing about the coordination between the two alignments. So, these factors which we have looked at, we can stop here and we will be looking at these surveys which are required to fix an alignment in our next interaction, as now we are out of time, and we will be continuing with all of these surveys in the next lecture, as I said. Till then, thank you and goodbye.